Hi, welcome to today's lesson. Today in class we're going to be talking about trig ratios. To start our talk on trigonometry, today we're going to be talking about trigonomic ratios. Trig functions are ratio functions for right-angled triangles. That's our first thing we have to learn, is that when we're talking trig ratios, we need a right-angled triangle. Just to review, a right angle means we have a little box here, means that's 90 degrees. Across from that, if this is angle capital C, we have side small c. If this is angle big A, we have small a across. If this is angle big B, we have small b directly across. Across from our 90 degrees is the hypotenuse, and we have legs A and legs B. Let's look at our first trig ratio. If we're talking about sine theta, that means we're going to be looking at the ratio of the opposite over the hypotenuse. If we define theta as A, the opposite will be small a over the hypotenuse. The hypotenuse is always across from the 90-degree angle. So our ratio of sine theta is the opposite of theta, which is A, over the hypotenuse, which is C. Our second trig ratio is cosine theta. Again, if we define theta as being angle A, then cosine theta means we're going to take the ratio of adjacent over hypotenuse. Well, the adjacent angle to A is B, and of course the hypotenuse remains across from the 90-degree angle. So cosine theta will be B over C. That's small b over small c, because we're talking about the ratio of the sides. Our third trig ratio is tangent. Tangent is defined as the opposite over the adjacent of theta. Well, we've defined theta as this angle A. The opposite of A is A. What's adjacent to A? Well, that is side B. So if theta happens to be angle A, capital A here, then tangent, which is opposite over adjacent, is A over B. Well, it is true that tangent theta is equal to the ratio of the side opposite the angle over the side adjacent to the angle. Tangent theta is also defined as sine theta over cosine theta. Of course, we have a restriction where the denominator cannot equal 0, so cosine theta cannot equal 0. One of the things we can do with right triangles is, given any two sides, we can solve the third side using something called Pythagorean Theorem or Pythagoras Theorem, which states that a squared plus b squared equals c squared. Notice c squared is always the hypotenuse. It's across from our right angle, and A and B are the legs. So we have leg, and hypotenuse. So the leg squared plus the leg squared is equal always to the hypotenuse squared. It's important that you put the hypotenuse squared on the other side of the equal sign. Let's now talk about converting angles from degrees into minutes and seconds. Here we've been given an angle of 43.62. This little symbol here means degrees, and sometimes you're going to be asked to convert this into minutes and seconds. Well, this is 43 degrees. We're all set here. 0.62. Well, this is 0.62 degrees out of one whole. We have 43 whole degrees, and we're not quite at 44, but we've got 0.62 out of one whole extra degree. Well, how many minutes is that? That's x minutes out of 60. If we can think of a clock, we know that there's going to be 60 minutes. 0.62, well, if here is half is 0.5, 0.62 may be somewhere in that direction, about like that. I'm just thinking, what's about 60% of that? If I shaded all of this, I'd have about 62% of a clock. Well, I want to know how many minutes that is. It looks somewhere between 35 and 40 minutes. Well, how can I tell? I can set up this ratio. 0.62 is to 1 as x is to 60. Cross multiply, and I get x is equal to 0.62 times 60. So x is equal to 37.2. This 37 is the number of minutes. So I can say I have 43 degrees and 37 minutes. But it's 0.2, 37.2 minutes. So I also have to convert that to get seconds. 0.2 is to 1 as x is to 60. Again, I cross multiply, and I get x is equal to 12. So that will give me 12 seconds. And it matches up with my picture that I should have somewhere between 35